Okay, so now we have to do point elasticity, right? So now we have seen the linear curve, we have seen the non-linear curve. Now we are going to look at the linear curve. Whenever the graph is a straight line, all right, whenever the graph is a straight line, we can find elasticity on any point on the curve, right? And the elasticity of demand at any point on a straight line is point elasticity. Basically, if you want to define it, that's the definition. The elasticity on any point on the demand curve is the point elasticity. So let's quickly look at the calculation, how we have to do it. It's very straightforward and nothing more is required than a basic understanding of this. So let's look at a sample question and then we will try to understand it according to that. Okay, so let's look at the formula. The formula of point elasticity is whenever you have a straight line, you will divide it into two parts. Okay, you will have an upper part and you will have a lower part. Those parts are called the segments of the line. Alright, the parts, the divisions are called the segments of the line. So the formula is very simple. It's lower segment divided by upper segment. Finish. Okay, we are not looking at any delta formulas. We're not looking at any change formulas in quantities. It has to be a very straightforward, formula. Nothing complicated. Let's not complicate things. So we have a straight line. Whenever there's a point, if you put a point on a straight line, okay, let's say you put a point here on a straight line, what are you doing? You're essentially dividing the straight line into two parts, an upper part and a lower part. The upper part is called the upper segment, the lower part is called the lower segment. So what you do in the formula is you put the lower segment in the numerator and you put the upper segment in the denominator. Alright? So let's try and understand this with the help of an example. Let's say that this is your straight line from point C to B. This is your straight line and the length of this straight line is 12. Okay, the value of the straight line or the length of the straight line is 12 and I put 4 points on this. I put point D, I put point A, point E. So what have I done? I have divided the straight line into 4 equal parts, right? So now let's look at the elasticity at any one point on this line. Let's say I want to start with point E. Okay, I want to start with point E. So what is the elasticity at point E? It's very simple. The formula is lower segment divided by upper segment. What's the lower segment? The lower segment is EB. Okay, EB, that is the lower segment because this segment comes below point E. And what is the upper segment? The upper segment is E to C. It comes above point E. Right? So here it is, EB divided by EC, the lower segment divided by the upper segment. Now what do? You simply plug the value of the lower segment and divide it by the upper segment. The lower value will be 3, okay, because we've divided the line equally. So the line was 12, we divided equally, so this is 3, and the upper is 9, so 3 divided by 9, 0.33, finish, that's the elasticity. Alright, let's come to point A. Alright, point A divides the line, this point divides the line equally in two parts. So the lower segment and the upper segment will be the same length. The lower segment is 6, the upper segment is also 6. The lower segment is AB, 6. The upper segment is AC, which is also 6. And the elasticity is 1. Alright, let's go to point B. Where's point B? Yes. Point B is here, the x-axis, okay? So what is the lower segment here? The lower segment of B is nothing. There's nothing below B. The line finishes at B. There is nothing. So nothing in math, of course, is 0. Divided by 12. 12 is CB. The whole length is 12. So anything, if you divide 0 by anything, your answer is 0. So the rule is that along the x-axis, elasticity will always be 0. Okay, there will be no response to any change in price. And what about this extreme, point C? At point C, the lower segment, now the lower segment is big, it is 12, CB, that's the lower segment. The upper segment, there's nothing above C, so nothing in maths means 12, so 12 divided by 0 is infinity, right? So we get this rule here. What's the rule? On a straight line, if you look at the center, any point in the center of the line will have elasticity of 1. Any point above this will have elasticity more than 1. Any point below this will have elasticity less than 1. This is the exact calculation that you have to do to prove this graph. Okay, this graph is proved correct. First you have to know that here elasticity is going to be infinity, here elasticity is more than 1, here elasticity is here elasticity is 1, here elasticity is less than 1. This is what you have to know first. Draw this, and then using mathematical manipulation, using this formula and these, maybe this you can use as an example, illustrate this. This is going to be important because the analysis is more important in the context of the case. The definition will be there, but that's a separate question. There is going to be an analysis, and this is the analysis. This is the kind of analysis that you are going to do. All right. So best of luck, and best of luck for the exam. Thank you.